Okay, hi there. Okay, here we go. We're going to practice solving a couple of equations and how we work across left to right, parentheses, exponents, multiplication, division, addition, subtraction, more or less in that order. All right, so let's get started. Now I'm looking at my little guide over here. I'm looking at this equation. This is what we're going to start with. And I see the first thing listed is parentheses, and I have a set of parentheses. So I'm going to solve that one first. 4 plus 1 is 5. And what I'm going to do, I'm going to keep the parentheses in there, because that parentheses means that it says 3 times 5. That's how we read it. Equals x. Because when we're working in algebra, that x has a change of meaning. So you usually see multiplication problems with parentheses, sometimes with the dot. So let's keep going. Now, I've completed that problem. What's next on my list? I look over and I see it's multiplication. So I'm going to do the multiplication problem next. 3 times 5 is 15. Minus 5. X. 15 minus 5 is 10 equals x. So now I know that x is 10. Fairly simple problem. They're not hard to do. It's just a matter of getting used to reading the problems in a new way. You're not going to see the typical way we handle problems when we're working with algebra. It's more left to right, identifying your parentheses, exponents, and just order of operations, all in all. All right, let's do another one. This time, let's go with 3 squared plus 4 minus 4 equals x. I want you to get used to seeing that x there, because that x, after a while, that x, it starts to move around, and it could get confusing if you're not paying attention. So, again, I'm looking, no parentheses, don't have to worry about that, but exponents is next. I have an exponent. This 2, I hope you guys can see that okay, is an exponent. That means 3 times 3. And we know that 3 times 3 is 9, not 6, 9. So 9 plus 4 minus 4 equals x. Now, I know there's a part of this equation, everyone's probably might be noticing this 4 minus 4. And we could do that real easily, just plug in the 0. But just for practice, I'm going to keep with following this and a basic left to right method of solving my problems, just to make sure I don't mess anything up. So I'm going to solve this one next. Now I'm going left to right. I have no multiplication, no division, no more parentheses, no more exponents. 9 plus 4, 13. Minus 4 equals x. 13 minus 4 is 9. X is 9. That's my answer. It's different than the way we're used to solving problems. It looks different, but it's basically the same thing. Once you get used to it, it just kind of begins to flow, and that's what we want. I gotta get a new board. This is looking terrible. Anyway, okay. Now let's start playing around with something that's a little bit more tricky. And for this, I'm gonna write this down. Yeah. And this is where we start using what we call inverse operations. That's when we're trying to isolate this x on one side of those equal signs. Now to do that, remember last week I covered it briefly, we start using what we call opposites, the inverse operations. I have a positive 6 here. There's no sign in front, so I know it's positive. I could plug one in just to be sure. If there's no sign, it's positive. The only time you know it's negative is there will be a negative sign. But anyway, to get rid of this 6, I just do the opposite. I do the inverse operation. I subtract the 6. But whatever I do on this side of the equal sign, let's do this. I'm going to put a line all the way down, just to make sure we know what we're talking about. Kind of as a guide. Whatever I do on this side of the equal sign, I have to do on that side. Okay? That's 0, and like I told you guys last week, we're not going to bother writing our zeros. We know it's 0, there's nothing there, there's no value there. I'm just going to bring down my x. 11 minus 6 is 5. So the solution to this problem, x in this case, is 5, which we can figure out with basic algebra, but we're practicing the steps. We're practicing how we do these problems. All right, let's erase this one. I'm going to try writing a little bigger. That looks like it might be kind of small. Let's do another one. This is going to be a little trickier. Now, I want you guys to think about that number line that we talked about earlier. We're going to start playing with negatives and positives. X minus 7 equals 15. Well, inverse operation. In case anyone has any doubts, that is a 15. So the inverse of negative 7 is positive 7. Okay? Oops, I don't need that just yet. And that's 0. So I'm not going to bother writing the 0. I'm just going to bring down my x. I can move it over a space. And voila. Oops. Ah! What I do on one side, I do on the other. That's 0, so all I have is x. But 15 plus 7 is 22. Sorry about that. Okay, what I do on one side, see, that's why I need that line. I got to remember to do that. What I do on one side, I do on the other. X in this case is 22. 22 take away 7 is 15. Okay, I hope that's kind of making sense. I'll try not to make any more mistakes. That doesn't help any. Now, remember what I said about that number line. That's where we starts to make a difference. Let's redo this one again, only just a slight change. X plus 7 equals 2. Okay? So, same thing. I want to isolate this x. To do that, I need the inverse operation. That means positive 7, in order to get rid of it, I need negative 7. I always work on the side where my variable is. What I do here, I got to do on this side. Now we know 7 take away 7 is going to be 0. I'm going to bring down my x. But as we talked about with the number line, let's make a quick number line here. And let's go 0, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. So here, this is 2, 3, 4, 5. Just to make sure everybody's clear. And this is the negatives. 2, negative 3, negative 4, negative 5, so on. So I'm starting on 2, positive 2, negative 7. That means I have to go this way. Negative is always left. So 1, 2, 3, 4, 5, 6, 7. Negative 5. And that's my answer. In this case, x is negative 5. Negative 5 plus 7, a positive 7, is 2. Right? Because there's negative 5, and now if I add 7, negative 5, I'm sorry. 1, 2, 3, 4, 5, 6, 7. And that's where I end up. Okay? I hope that was clear. Let's do another one. That may not have been clear. I want to be sure. Let's start with the negative. Maybe that'll be a little clearer. Negative 2 plus x equals negative 5. All right, I'm gonna make me a little number line here. Again, 0, 1, 2, 3, 4. I'm gonna have to go a little further. 1, 2, 3, 4, 6. And these are all negative numbers. So I'm putting the sign there. Okay, so inverse operation. I have negative 2 plus x equals negative 5. I have to add 2. That is the opposite of negative 2. I'm working on this side because that's where my variable is. That is 0. I'm just going to bring down my x. Plus 2. Negative 5 plus 2. Well, look down here on my number line, and if I add 2 positive, that means I have to go that way. 1, 2. And that gives me negative 3. So in this particular case, x is equal to negative 3. 2 negatives make a positive. Okay? I hope that was clear. Made sense. And we'll talk about it in class, hopefully clear up and I didn't confuse anyone anymore. All right, bye.